Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything covered in week 2. So we did two things that were new, exponential equations and also exponential modeling. So exponential equations are when you're solving an equation and the unknown is part of the power. So there are three ways to do it. You can equate powers, use logs, or use technology. So we're going to equate powers in this one. So what we're going to do is first add 5 to both sides. So then we get 3x plus 2 equals 81. We're solving this like a linear equation, undoing everything done to x in the opposite order to BIDMAS. But BIDMAS after B brackets is I index. We raise the power before we do any multiplication, subtraction, division, or anything like that. So that's why I added 5 first. So to solve this equation, note 81 is actually 3 to the power of 4. So we can equate powers here. So because the bases are the same, the powers must be the same. So x plus 2 must equal 4, x equals 2. Okay, that was nice and simple. It won't always be this simple. We won't always get a nice power of this base. So for example, if I look at this equation here, so first thing I'm going to do is divide each side by 4. But then I get 2 to the power of x equals 3. This isn't so straightforward. Unlike in this one, 81 was a power of 3. It was nice and simple. 3 is not a power of 2. We're going to get an irrational solution here. So we have to use logs or technology. So if you're using logs, all we need to do is say x equals log 3 over log 2. Put that in your calculator, you get about 1.58. That's how you do it using logs. Now, if you don't know what logs are, you find them difficult, you will have to use technology. So how would I do this using technology? Well, what I could do is I could graph y equals 2x. I could graph y equals 3 in my graphics calculator and get my graphics calculator to calculate the point of intersection of these two graphs. The x-coordinate of that point of intersection is 1.58. So either way you want to use it is fine. All right, let's do an exponential modeling question. So exponential models are where we're modeling real-world situations with an equation of this form. Y equals something times a to the power of something. So if this number here is more than 1, you have exponential growth. If this number here is between 0 and 1, you have exponential decay. We're only looking at situations where this number here is more than 0 but not equal to 1. So an example of exponential growth is with compound interest. This is where something is increasing by the same percentage each year. So let's look at this question. Say we're getting interest compounded annually. We have this much after 3 years, this much after 7 years. We're going to find how long it will take to reach this amount. So to do that, I need my equation of this form. So K, it turns out, is the initial value, and A is the rate of growth or decay. So in order to know the equation for this compound interest, the equation that looks like this, I need to find the initial value and the rate of growth or decay. So no matter the context, if you have two unknowns to find at the same time, you should think simultaneous equations. So I'm going to turn this bit of information into an equation and this bit of information into an equation. So 24,747 after 3 years. So I'm going to let y be the amount and I'm going to let x equal the number of years. So when x equals 3, y equals 24,747. Y equals k times a to the power of x. So after 7 years, y the amount, 28,950. So that's equal to k a to the power of 7. So how am I going to solve these simultaneous equations? Well, I need to get rid of one of the variables. It turns out if I divide this equation by this, I can get rid of the k's. So if I divide this by this, I end up with 1.169838 so on, equals, so k divided by k cancels out, a to the power of 7 divided a cubed is a to the power of 4. So to solve this equation, I take the fourth root of each side. The fourth root of this number gives me almost exactly 1.04. So 1.04 means that it's increasing by 4% each year. So I can easily find k by substituting back into, say, this equation here. So I take 24,747, divide 1.04 cubed, I get around about 22,000 is equal to k. So that means the equation is y equals 22,000 times 1.04 to the power of x. So this person has invested $22,000 at 4% per year. So if I want to know how long it will take to reach 35,000, I just change y to 35,000. So we divide each side by 22,000, and we have this exponential equation, exponential because the unknown is part of x. So we can either use logs or we can use our graphics calculator. So if we're using logs, x would just be the log of 35 over 22 divided by log of 1.04. If we don't want to use that, what we could do is graph y equals 35 over 22, y equals 1.04 to the power of x, and then get our graphics calculator to calculate the point of intersection. So either way, you get about 11.8 years, but we need to round that up to 12. So you would need 12 years in order for your investment to reach 35,000. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.